Okay, this tutorial deals with section 5.5, solving quadratic equations. And our first technique is the zero principle. If you check on page 164 of your Math 830 textbook, they have the zero principle, and basically stating that if you have two factors that multiply to zero, one of those factors has to be zero. And that we can use to solve particular kinds of quadratic equations. So we've got a few examples in here, and it's fairly simple. If you want to solve this here problem that is a quadratic, that equals to zero, all you have to do is you have to factor the quadratic. So this is a simple trinomial, so factor first. So that would mean two numbers that multiply to 15 and add to 8, since this is plus 8x and this is plus 15. So that'd be x plus 3 and x plus 5. They multiply to 15 and add to 8. And then just equal them out to 0. Two possible answers. Solve for x in each of these, and x is going to equal minus 3, or it could maybe equal minus 5, or negative 5. Okay, that's a simple trinomial example. What we want to look at now is something a little more complex. Sometimes you have to do a little more factoring than that. So in our next example, we have something that's going to use decomposition. We have 28x squared plus 33x plus 10 equals 0. So that means we have to multiply, if we look at these two numbers here, these two numbers here, it has to multiply out to 280, and it has to add to 33, so that we can decompose our 33 into two different numbers and then factor that way. It's called decomposition method. So two numbers that multiply out to 280 and add to 33 are 7 and 40, being positive 40 and negative 7. So let's decompose it into 40x minus 7x. That's how we decompose our 33x. And then we can factor out a common factor for this double set and this double set. So what can come out of here is a 4x. So that would leave us with x, 7x plus 10. So then that means we have to take out a negative 1 here to get minus 10. Yeah, plus 10. We have to take a 7x out here. Minus 10. I think this needs to be, let me check my number here. Yeah, this needs to be a minus sign. That was my mistake when I wrote it down from my example here. Otherwise, this doesn't work out. Let's pretend that was a minus sign, because we have that. So if that's a minus sign, then this will just be our minus 10, or plus 10 here, because of this minus 1 out here. Sorry about the sign here when I was copying the question down. So then we have 4x minus 1 multiplied by 7x plus 10 equals 0. So then we just solve for x in each of these. So 4x equals 1, or 7x equals negative 10 as I'm moving over. So then this would mean x could equal a quarter, or x might equal negative 10 over 7. So that would be an example of using decomposition. So our next example here, we have to take out a common factor first. So take out a 2. And all that does is, when we change it into another trinomial, then we can factor that trinomial into two numbers. Okay, we have to look at, multiply to negative 5, add to positive 4. So that would be negative 5 and positive 1. Okay, so that would mean x can equal 5, or x can equal negative 1, as I solve for x in each of these two. 2 just stays out there. So I'm going to flip over the page and look at another few examples here. You don't have always to worry about not necessarily having a trinomial there. If you had something like this, you could still take out a 4x. And this would give you x minus 3. So this still says that 4x can equal 0, or x minus 3 can equal 0. So that would mean if we divide out the 4, x can equal 0 or positive 3. Okay, and sometimes, I know I've worked them all out nicely, but sometimes the trinomial is mixed up and you have to arrange it in the, put the x squared, then the x, then the number, equaling all to 0 before you do it. But it's the same principle. I'm going to move to our last example here. Sometimes you have fractions. When you have fractions like this, all you have to do is multiply by the common denominator, which would be these two things multiplied together, to eliminate that common denominator. So you'd have a over a plus 3 times a plus 3, a plus 5 together, like that. And the same here, except it's a plus 5 for this expression. Okay, and the last thing with the 1/8, you're going to have both of those together. So you can see that these eliminate. So I have a times a plus 5. These eliminate. And I have minus a times a plus 3 equaling, as you can see, I forgot to put the 8 in there, right? Because you have a common denominator of this 8 to eliminate this 8. So you should have had an 8 there and an 8 here. So we'll have to add that into our equation here. Starting off slow this morning. Okay, don't forget the common denominator has to be all three terms like I did there. So you need to add the 8 in here as well. And then obviously we'll put the 8 here. That'll eliminate this 8 here. Okay, my apologies there. Don't forget about the... And then that leaves us with these two binomials together. So now all we simply do is we work this out and solve for a. So this is 8a squared plus 40a minus 8a squared minus 24a. And if we work this one out, that's going to equal a squared plus 8a plus 15. So this is one of those questions where you're going to have to rearrange it all so that you finally get a trinomial in the end. Okay, so these cancel out here, because one's positive, one's negative, and you've got 40 minus 24a, so that's 16a on this side, equaling a squared plus 8a plus 15. So obviously I want to bring the 16a over here. So 0 is equal to a squared minus 16a from both sides, so this would give us minus 8a, right, plus 15. So now I have to look for two numbers that multiply to 15 and add to negative a. So then that works out to a minus 3 and a minus 5. So then a equals 3 or a equals 5. And that's an example, a few examples of how to do factoring by the zero principle. Apologize again for the forgetting of the 8 there, but remember when we work that out, you have to have the common denominator of all three terms. I only did these two when I started, but realize that we have to add the 8 in there as well. So in our next tutorial, it will be section 5.6, and we'll be looking at the square root property.